Hello everyone, and welcome to the Green Power Future Mission National Pilots webinar series. This is the fourth in the series, and today we're going to be hearing from National Grid and the newly formed National Energy System Operator, or NESO in the UK, about two projects on vehicle-to-grid V2G and the virtual energy system. And I'm delighted to be joined today by some of our colleagues from National Grid and NESO, and I'll let them introduce themselves at the appropriate moment. But first of all, for anyone in the audience who might not be familiar with Mission Innovation and the Green Power Future Mission, I'll go through some slides now. So Mission Innovation was launched at COP21 in 2015, and it's the main intergovernmental platform for accelerating clean energy innovation, involving 23 countries and the EU, represented by the European Commission, as well as several collaborating organizations. And these members are responsible for greater than 95% of public clean energy research, development, and demonstration investments globally. So Mission Innovation is structured around 7 missions, which are public-private alliances that are setting goals that will lead to tipping points in the cost and scale of clean energy solutions. The 7 missions are shown here on the slide, but we are the Green Power Future mission, so I'll talk a bit more about that. So the GPFM's goal is to demonstrate that by 2030, power systems in different geographies and climates are able to effectively integrate up to 100% variable renewable energy in their generation mix, whilst maintaining a cost-efficient, secure and resilient system. And we do this through knowledge and capacity building by demonstrating innovative solutions and generating the tools, data, and networks needed to enable more regions to be powered by affordable VRE. Like all of the other Mission Innovation missions, the Green Power Future mission is a public-private partnership made up of in-kind contributions from its member countries and organizations. It's co-led by Italy, China, and the UK, and you can see the many other international members we have in our coalition on the screen there. The mission splits its work across 3 main pillars. The first is led by China, focusing on the generation of renewable energy from the likes of wind and solar power. The second pillar is led by Italy and focuses on the grid, system flexibility, market design, and regulation. And the third and final pillar, which is led by the UK, focuses on the data and digitalization of the electricity system. Now I'll talk quickly about the GPFM's first flagship project, which is the 5 Demos in 5 Continents project. So the goal of this project is to establish 5 large-scale demonstrations of innovation activity in the 5 continents of Asia, Australia, Europe, North America, and South America, which can demonstrate up to 80% VRE integration by this year, 2024. And these demonstrations are made up of 80 national pilots on the scale of millions of euros and are aimed at reaching technology readiness level 6 to 7. And each of these national pilots is tackling one or more of the 50 most urgent innovation priorities that were identified by the mission, driving us towards the 80% VRE integration. Now you can find out more about all of the pilot projects in the National Pilots Report, published in the GPFM section of the Mission Innovation website. And there you'll also find more of our core documents, such as our action plan and our annual reports. And then lastly, just before we get started today, I wanted to show you all the webinar schedule as it stands currently. So you can find the links to the recordings of the previous webinars through the GPFM website, and we'll also be posting it on our LinkedIn. And then today, of course, we have National Grid and NESO. Then in November, we'll have some speakers from the Longer Duration Energy Storage Programme, which is in the UK. In December, we'll have our GPFM conference in China, so we won't be having a webinar that month. And January is, of course, a very quiet start to the year. So we'll jump straight to February, where we'll feature Icebreaker 1. And then beyond that, we're still looking for volunteers from our GPFM members, so we'll keep you informed about that going forward. So on to today's agenda. The main goal of the Green Power Future mission and Mission Innovation in general is to facilitate knowledge exchange between its members and other interested parties to catalyze and accelerate innovation around the world. And so that's why we've set up this webinar series. so that everyone here, the pilot project leads and other interested innovators, can discuss ideas, their progress, and lessons learned along the way. So this is meant to be quite a relaxed exchange where a few project leads will give short presentations before we open the floor to some hopefully quite fruitful discussions. So please submit your questions at any time into the Q&A box, or use the chat if you wish throughout the two talks. We'll do both talks one after the other, and then we'll get to all of the questions at the end. And you're also welcome to raise your hand if you wish to be unmuted, and you can ask your question verbally. And so with that, I will hand over to Tim, who will be opening with a bit of an explanation about what has recently happened with National Grid and NESO. So over to you, Tim.
Yeah, cheers. Thanks, Craig. Luckily you won't have to hear from me for long, but I would just want to kind of give a really kind of brief overview of what National Grid's involvement has been in the Green Powered Future mission, and the what's happened, particularly with the move to NESO as well in the last month. So National Grid joined the Mission Innovation back in 2021. At that time, the electricity system operator in the UK was owned by National Grid, albeit as a separate legally separate company. So that means we took into account as National Grid all the different innovation projects that was happening across our whole portfolio, and that included kind of the system operator. And that also meant that when it came to submitting pilot projects for the National Pilots Report, which Craig just mentioned, we pulled from all the areas of National Grid. I think we submitted 8 in total. Some were from the UK transmission business, National Grid, and Neha is going to be talking through one of those today. Some was from a distribution business in the UK, and some were from the electricity system operators. And again, one of those you'll hear from today from Greg. So at the start of this month, the ESO was no longer part of National Grid. It's become NESO, which is the National Energy System Operator. That is wholly owned by the UK government. And I think it's very important just to make it clear that we are now kind of completely separate companies. We do different things within the market and the energy system in the UK. I just thought it was really probably useful just to highlight that, and just to make it clear that if you're looking over some of the previous documents which have been kind of created in years past, you may see National Grid as the owner of certain innovation projects, but they may have moved over to NESO. Yeah, I think that's all I really wanted to say. I think if anyone has any questions about those at the end, happy to answer them. But hopefully the questions will be about the innovation projects from Neha and Greg. But that's it from me, and I'll pass over to Neha now. Thanks a lot. Oh, Neha, I think you're still muted.
Yeah, I'm sorry. I just realized as I started talking. Back to presentation mode. All right. Well, thanks, Tim and Craig, for the introductions. So as mentioned, I'm from National Grid. Firstly, I'm Neha. I work in the Net Zero Innovation team in the electricity transmission side of National Grid. My current work experience is in the whole system portfolio space within the innovation team. So I look after any projects that impact industries that work in silo with us. So that could be transport, energy water interactions, for example, and V2G definitely falls into my portfolio of works. Prior to my job at National Grid, I was working in Australia in the customer connections team at a distribution utility. So my predominantly my work experience has been as a power systems engineer doing connection studies on PSCAD, PSC type platforms. So yeah, this has been quite the change, but it's been exciting being part of the innovation team here. So as you can all see, the purpose of my presentation today is to give a showcase of one particular project in my portfolio called V2G peak demand reductions. I'll first spend a couple minutes talking about the motivations behind the project, and also talk about the current landscape, and what the drivers are for this project, and then launch into the details of the innovation project, who was involved and the objectives we were trying to achieve. Then I'll talk about where to from here, just to talk about the lessons learnt. And then I'll conclude, and of course there'll be time for questions at the very end as well, as mentioned earlier. So, as we all know, electric vehicles are anticipated to become a major source of electricity demand by 2050. We can expect to see at least 19 to 26 gigawatts added to peak demand by 2050 as a result of electric vehicles. To combat this, there's a number of different technologies. So one upcoming technology is vehicle to grid, which is essentially energy going back from the EV battery to the grid. So it's essentially an additional source of energy which can contribute to the management of the system. There's a few different ways in which EV batteries can offer these services. So there's smart charging of EVs, where EV drivers allow the charging of vehicle batteries adjust to price signals. There's also deep V2G, which is where EV drivers allow vehicle batteries to engage in energy arbitrage. So that enables customers to export power to the grid at peak times when prices are highest, and import power from the grid when prices are lowest. And then there's also availability for system services, which is essentially where EV drivers allow batteries to be available for the provision of ancillary services to the grid, or participation in the balancing mechanism. Ofgem, which is the Office for Gas and Electricity Markets in Great Britain, they have done a bit of their own research and have mentioned that the combination of smart charging of EVs and V2G together could reduce peak demand by as much as 32 gigawatts by 2050. That can actually offset the demand that comes from EVs in the first place. So to explore that concept a bit further, we decided to pursue an innovation project in collaboration with a few different people. So before I get into the details of the innovation project, I will talk about the current landscape that we are looking at. So there's a few different drivers for potential peak demand reductions. Consumer behaviours is a really big one. Traditionally till now, we focused a lot on the technical implications associated with EVs and V2G technology, but consumer behaviour hasn't gotten as much attention as it needs to, and it's one that's really important because without getting consumer support and willingness to adopt V2G technology, we're not going to see V2G succeed as much as it could. So consumer behaviours is a really big aspect of the project, and you'll see that later on. Also, development in battery technology. As we know, developments in battery are growing quite exponentially, and that's also driving sales in EVs, which then also drives innovation within the V2G space as well, and that becomes a cyclic nature. So we're expecting to see a lot more EVs connect to the network in the future, meaning there's a lot more potential to leverage V2G as well. Developments in charge point technology. So this is an important one because it really dictates how willing our consumers are to adopt V2G technology. And that really comes with improvements in the infrastructure that we're willing to engage in the future. So making sure we have enough charge stations for customers so that they are willing to adopt EVs will also foster greater deployment of V2G technology. So some key research areas that we wanted to target through this project is, well, how can we reflect the uncertainty around behaviour and technological progress of smart charging technologies? Also, is there potential for V2G and smart charging to have a positive impact on peak demand? or is it just going to be another source of stress to the grid at peak times? And then number 3, can V2G and smart charging participate in system services? So those are some of the objectives that we wanted to achieve through an innovation project. So in order to scope out this project, we had to engage with a number of different suppliers external to the business. So firstly, we worked with Frontier Economics, also Imperial College and the University of Warwick, and they all collaborated with each other to develop a electric vehicle model, which was an agent-based model, and it represented a real physical space in the UK. I believe the real physical space was somewhere in the region of Nottingham in England. It was a 40 by 40 kilometre area, and it was then scaled up to represent the rest of GB. But fortunately, that physical space had characteristics that were quite representative of the wider network, hence why it was selected as the region. And then following on from that, we performed a number of qualitative and quantitative behavioural surveys of current EV drivers to understand or extrapolate how that behaviour might evolve in the future. And that then informed the model that was constructed by our suppliers. Following on from that, we had to represent the uncertainty around behaviour and technology progress. And that was done through 5 different sensitivities. So we had a highly favourable sensitivity straight through to the highly unfavourable sensitivity. The highly favourable sensitivity assumed that customers were willing to adopt V2G technology. There wasn't a lot of hesitation associated with the battery degradation that comes with the charge-discharge cycles with V2G charging. And overall, there was a large number of customers purchasing EVs and participating in V2G. The highly unfavourable scenario assumed that technological advancements did not progress as quickly as we would have liked it to, and that therefore impacted the adoption of V2G technologies. So having that range, those range of sensitivities allowed us to capture the range of results that or the success range of V2G technology. That then enabled us to assess the overall impact that V2G and smart charging could have on potential peak demand reductions. And I'll have some figures on the next slide as well as an example. But this project was very broad. It was a very it's a low TRL project, meaning technology readiness level, meaning that a lot of the work was research heavy, and the key learnings came from the model that was developed and served to inform internal planning teams on how they can better manage the network, for example, in the future in terms of infrastructure requirements. So moving on to the next slide. So some of the key learnings from the project. So firstly, cost reductions in V2G enabled charges will be required. That's an obvious one. So without the reduction in V2G enabled charges, we won't see the uptake of it, and therefore we're not likely to see any peak demand reductions coming from EVs. Also, EV drivers will need to be confident that deep V2G will not degrade their batteries. So Warwick University did a lot of studies around this and were able to quantify the impact on battery capacity associated with charge-discharge cycles. Also, it's important to note that consumers and network service providers can have conflicting priorities when it comes to charging of EVs, and this is where incentives come into play. So it's our responsibility to make sure that our consumers are also getting best value out of the solutions we propose for the network. Another point there is reducing the hassle associated with plugging in when required. This is associated with the infrastructure requirements that we'll need to see in the future. Without new charge point technologies, we're likely to see customers associate charging as being some sort of hassle, which isn't ideal for us when we're trying to reduce the contributions to peak demand. And then lastly, availability for system services is likely to be high, but technical uncertainties remain. I also have a table there. So this is just one example of results that came from a very extensive final report that came out of this project. So you'll see there's a few acronyms there. ST is system transformation, and LW is leading the way. So these are two of our future energy scenarios. Our future energy scenarios capture what the future network will look like in 2035 and 2050, and the technological advancements vary between each scenario. One of the main differences to note between these two scenarios is that the price differentials were quite different. So in system transformation, the price differential throughout the day was quite different. So customers were incentivized to engage in V2G in the evenings when peak demand was high, hence why you see significant reductions in gigawatts compared to leading the way, which has flatter price signals throughout the day, and customers are less likely to engage in V2G charging in that type of scenario. So how we structure incentives and the services that we offer have a huge impact on the success of V2G technology. So that's just one example of the outcomes from the project. I'm happy to share some other results that have come out of the study. We do have a number of reports, so I would have to look into what can be shared. But yeah, definitely happy to take questions too as they come through at the end. Thank you. I will pass on to the next presentation on virtual energy systems.
Right, thank you very much. Let me just bring my screen up. And hopefully everyone can see this now. Yeah. Great. So hi everyone, and thank you, Neha, for that presentation. So my name is Greg Johnston. I'm a digital energy specialist here at the National Energy System Operator. As was kind of mentioned a little bit earlier, we're recently minted as of last Tuesday, the 1st of the month, two Tuesdays ago. The NESO is an independent public corporation at the center of the energy system. So the virtual energy system is a program of work within our innovation space that is being incubated, and I'm just going to talk you through that for the next little while. So what on earth am I talking about, a virtual energy system? I think it was 2021, this kind of concept kind of came about. And to summarize it in a phrase, there's a long-term vision that we think there needs to be an ecosystem of connected digital twins crossing the built environment, energy, transport, water, all of it. We're particularly focusing in on the energy space right now, where models, data, information, decisions can be shared in near real time across the system, so that we can make more efficient decisions around running net zero power systems. So a significant amount of research has been done since that kind of project kicked off, this program. And if you like, the NESO through this program is the custodian. So the Virtual Energy System program is the custodian of that vision, of trying to bring the sector its capabilities through to realize that ambition. So we kind of looked at that and thought, okay, if you want to get to that space, what steps do you need to take on the way to get there? And the first thing that we really identified was this challenge around scalably sharing data between different organizations. And to give an illustrative example, if I can see 20 people are in this call, right? So if each if Neha and I we're two different organizations and wanted to exchange data, we would do a little bit of back and forth. We would get legal teams involved, our data teams. We would eventually share some data. It would take quite a lot of time and effort to do so. Now imagine I have to share data with everyone in this room. I'm doing that same thing and a further 18 times. And each one of you also have to share data with everyone else in this call. There's a huge amount of repetitive effort there to actually share data in a way. So we thought if we can scale a way to efficiently share standardized data across the system, we can lower the barriers to entry. We can start realizing that longer term vision of a connected digital twin ecosystem. And that's in a nutshell what the virtual energy system is trying to achieve. So I kind of gave a little bit on that. So how did we actually get to that point? So as I say, the virtual energy system program started in around 2021. And in around early 2022, an organization called Energy Systems Catapult published something called the Energy Digitalization Task Force. I would recommend it as some reading if you're interested. It made a number of recommendations to try and drive digitalization outcomes within the UK energy system. And one of its recommendations was this concept of a digital spine and a data sharing fabric. That concept has evolved into this, what we are calling the data sharing infrastructure now. And through the course of several years, there was activities being taken underway by ESO, so NESO's previous branding, and obviously ourselves to develop the thinking around, okay, what does that need to achieve? What's it trying to do? How can it go about doing that? And the Catapult proposed a very similar project. Our Department for Energy Security and Net Zero, so from which Craig comes from, the department published a tender for a feasibility study to look into this concept of a digital spine. That feasibility study was undertaken during the course of 2023, and its findings were published in July this year, 2024. Between the conclusion of the study and around July, yes, our NESO went away with the partners who'd worked on that feasibility study with some other identified organizations in the energy space, including Open Energy, our icebreaker one, which you may have saw in one of the early slides that Craig presented, that are going to be speaking in February, I believe it was. So we're partnering with them and others, looking at how we can realize this idea of a data sharing infrastructure. And on the left-hand side of the slide, it's kind of just tailoring out a little bit how we're taking that approach, and it's very aligned with developing digital services practices. So going through a discovery, what is it you're trying to achieve? How are you going to go about doing that? An alpha to try and really get into the weeds and the detail. And now we're moving through and transitioning to our kind of beta phase, where we're starting to develop toolings and capabilities to actually realize this concept of a data sharing infrastructure. One thing that's probably worth mentioning here is on the slide, Ofgem within their future system network regulation piece, which for everyone's benefit is a publication that was made looking at the next price control period for regulated networks in the UK. What sort of obligations will they have? What expectations are going to be put upon them? And within that, Ofgem signalled that this data sharing infrastructure is something that they viewed as quite important and is likely to be a requirement through the next price control period. So it kind of gives a little bit of weight and acceleration behind this kind of concept of a data sharing infrastructure. And again, it is NESO that's, as a custodian of this virtual energy system vision, kind of driving through the TRL adoption curve to bring this innovation into something that would hopefully be BAU, business as usual activity in the near future, hopefully. So part of the research that we undertook identified this need for a common framework. So I talked a little bit there about this data sharing infrastructure as the first step into this journey. And the common framework here is a number of key factors that we identified through our research to suggest, imagine this conceptually as if each of these boxes here, so creating a governance framework, managing security, or defining roles and responsibilities, if each of these were 100% of capability, they never will be, but if across the sector, but we aspire towards that. If as the capabilities or those boxes fill, if you like, the capability and the realization of that longer term ecosystem of digital twins becomes realized. So what we've, as NESO has kind of undertaken as part of this work, is identified a couple of the key early priorities within this common framework in order to accelerate getting towards that longer term vision. So, for example, in the people aspect, really trying to clearly define roles, skills, capability, and supporting the development of that across the sector. Looking at the data needs, and that's really driving at how do we ground data interoperability, the promotion of industry standards, and drive the adoption of those both in the activities that we undertake, but also in our partner organizations like National Grid, other networks, or anyone who participates in the energy system. So we're kind of taking this holistic approach, and as the program itself develops through time, we will be prioritizing each of these as we kind of identify the need to grow capability of ourselves, but also the sector. So that kind of leads to, well, what actually can you achieve with better data sharing and this kind of longer term vision? So I kind of alluded to the idea at the start that we want to get to a space where there is connected digital twin ecosystems where organizations are bringing in data, doing lots of very clever things with it, coming up with information or making decisions and being able to share those models and such very quickly with other organizations as required. That has any number of use cases, and we have a backlog of, I think, 26 ones that we think could be realized in the coming years. But try and look at a couple of specific ones. Some of you may be familiar with NESO's CrowdFlex program, which is an adjacent program of work to the virtual energy system. It is separate but adjacent, looking at how we enable domestic flexibility. And how does a better data sharing environment help drive domestic flexibility, I think. There are a number of ways in which that happens, either organizational data sharing or data sharing from the devices themselves into the market and how that interacts with both kind of processes, systems, but also kind of like the marketplaces for domestic flexibility, for example. How do we look at the different energy vectors and how do we start scalably sharing data? I think this energy transition will it will require us looking across vectors, so gas, heat, hydrogen, electricity, and being able to bring those data sets together and start doing more interesting things. One is a key priority of the program. And for those of you not intimately familiar with NESO's responsibilities, we do have a responsibility around strategic planning of the energy system. So not just electricity, but the vectors that I already mentioned. So we're exploring in our next phase of work how we can do that strategic planning across vectors. We have been collaborating with gas distribution and gas transmission, for example, in the development both of the common framework, the previous slides, and we are exploring with them how they can interact with this system as we kind of develop it into the next phase of work. So opportunities, I think any of you following what I'm saying, hopefully swimming with opportunities in your head and, oh, I could use that. But fundamentally, there's some really basic stuff. I kind of described the challenge of sharing data between organizations, all of the legal, just the time consumed to actually get data from A to B. We really think that the development of the virtual energy system program, and in particular our first step, this data sharing infrastructure, will really lower the barriers for sharing data, which fantastic. Okay, data's got from A to B. That's one part of the challenge. Now, how are we going to use it? Who's going to be using it? For what purposes? But when we get, as we start overcoming those challenges, then you start really unlocking huge amounts of value. Being able to identify and reduce risks and costs of the system, being able to see things that you weren't able to see before. Because fundamentally what we're talking about here is the exchange of shared data. So I think the UK has done a very good job in the energy sector in particular, and opening up data and making it freely and publicly available. And there's lots of innovative companies coming out and doing interesting things with that. What we're really here describing is how do we share data between organizations that can't necessarily be made publicly open. And as we develop those capabilities through time, being able to share not just data, but models too, then we can evolve the sector's modeling capabilities. So just to give you a little bit of a high-level roadmap of where we are with this innovation, you can see on the screen here a kind of timeline out to 2035. Just to be very clear, we're not saying that there will be nothing ready until 2035, but just to illustrate that we believe on this kind of iterative development cycle that we are scaling through time to add more capability, more data sets, more tooling capabilities and such as we progress through that the early 2030s and beyond. But just to highlight a couple of key points on there, I talked about price control periods for the regulated networks. You can see indications on here of the RIIO T3 and GD3, so that's transmission and gas distribution, and then ED3 is electricity distribution. And they are two different periods where the next price control comes in with the regulated networks. And as I suggested earlier, our regulator, Ofgem, is looking at putting a requirement to use this data sharing infrastructure in alignment with the changes in those price control periods. So just to kind of zoom in on where we are today, just to illustrate, and I won't go into any more detail and I'll kind of wrap up here, is to say that we're currently developing our pilot around outage planning use case. We will next year be looking at our strategic planning use case, which, as I say, is looking a little bit more cross-vector to enable data sharing and outcomes around there. And then towards the tail end of that period, we'll be starting to bring online more and more use cases, more and more exchanges of data, more partners, and developing this ecosystem of data sharing through the late 2020s is the ambition. So I'll stop there, and I believe whether it's Craig or Tim probably come back on and we'll start taking questions for Neha and myself. Thank you.
All right, thanks very much to Neha and Greg for a couple of great presentations there. So the floor is now open for questions, but I can see that none have been posted yet, so I'll take the chair privilege of asking the first one. So the first one I have is for Neha. So you mentioned in your talk that it's important to bring down the cost of the V2G enabled chargers. And I was thinking, that in order for that to happen, you need an impetus to sort of spur investments in bringing those costs down and the right policies. But to get that, of course, you need proof that it works in order for people to be convinced to make those investments. So I was wondering if there was a plan to sort of deploy this on a small scale, perhaps in Nottingham, where you did that initial small modeling. Even though that at this point it's quite expensive to do so, is there a plan to deploy it on a small scale and show that it works before then scaling up?
No, so far it's just all been model-based simulations, not working with any real-life technologies at the moment. Also, given that the area that we looked at, we've had to make a lot of assumptions around the the wider network that it's representing. But in terms of, you're absolutely right, we need to see reductions in the technology in order for it to be adopted in the future. And that really comes down to, I guess, the business case that we put forward within and Get Alone. So by demonstrating the value that V2G technologies can have on the network in reducing peak demand and therefore reducing the requirement for transmission infrastructure, from a utility point of view, we could use innovation funding to support the development of those types of V2G technologies. So that's something NGET could do to help accelerate that further. But the developments in the technology itself would be driven by the manufacturers that are out there and the technologies that are becoming available on the market.
Okay, great, thanks. All right, now I also have a question for Greg. So you mentioned the importance of standards for data sharing and interoperability. And this is something that the GPFM actually focuses quite a lot on in Pillar 3 under Data and Digitalization, which is led by the UK, i.e. myself. And so I was thinking, this clearly involves many stakeholders, right? Getting them to agree on these standards. And some of those stakeholders are members of the mission. So you mentioned Icebreaker 1, for example, and there's also BSI, the British Standards Institute, who are working on this kind of thing. So really my question is, I'm wondering how at this stage, before you've agreed on all of that and you're building it towards it, how are all of these different stakeholders sort of kept informed of how it's going, essentially? Because, you touched at the start of how complicated that really can be if everyone has to get all their lawyers involved. So how is everyone kept informed? But then also, how could perhaps the GPFM help?
Yeah, so one of the ways in which we've been doing that, we were running advisory groups for a good long while, which covered topics like governance primarily, and it was looking at items around how do you govern this concept of a data sharing infrastructure and the development of this. Is kind of, those are two separate things to an extent as well, but also how does the data sharing infrastructure, how does that decide on things like standards? I think where we came to was that we don't view either the virtual energy system as that custodian of the vision, or the data sharing infrastructure, which, if you like, is a technological and governance kind of wraparound to enable shared data. Neither of those two things are standards bodies. So what they're there to do is to help bring standard bodies and others together and say, okay, and an example of this would be that the development of our pilot, we need to pick a kind of standard around what we're sharing, right? So we are engaging with BSI, we've been engaging with through our advisory groups, we've been engaging with the market around like, okay, how do we actually realize this to test it in a pilot use case? So for the strict confines of the pilot, there is the development of something called the GBSIM model, so the Common Information Model. So we were looking at, okay, for the purpose of this pilot, there is enough within the GBSIM that we can use that to leverage to demonstrate the capability of being able to share GPSIM files between different market participants. So kind of using the kind of stakeholder network, if you like, that myself and my colleague Anka, who's on the call as well, has been developing over a number of years to help make a decision, and then, okay, we'll take that forward. And then the actual concept, if you like, and again, we're still working through this as pilot innovation at this point, but I think the concept is that the data sharing infrastructure would enforce standards that have been decided elsewhere. So, for example, if the regulator Ofgem turned around within a guidance or a direction to networks that said, you must now use standard XYZ, then the data sharing infrastructure can enforce that across the peer-to-peer exchanges that it enables. So that's kind of how we're treating it. So it does kick the question away slightly, but the idea is that both the VES and the data sharing infrastructure are facilitators for the great work others are doing. We don't want to duplicate where we can avoid it. And then it should help us identify where no one is acting on standards around particular instances and drive our stakeholders to either go in, solve that challenge, and then we can help implement the solution. So that's kind of how we're viewing it.
Great, thanks. I'm still not seeing any questions, but those of you still on the call, please do post some questions. But in the meantime, I do have one more for Greg, and this was about the importance of telecoms. So presumably this data sharing infrastructure is going to work primarily, through the internet, and so this is clearly something that's going to be very important. So I'm just curious, kind of how you're working with telecoms companies in the UK. Is there one in particular, or do you have to work with many of them? Curious how that side of things works.
So actually, at the moment, where we need to explore more and where a little bit the focus is actually in the cloud service providers rather than telecoms themselves. So we are exploring like how can the technology be deployed across different cloud environments or on-prem environments, for example, and how can that can the technology actually exchange information between different cloud providers and be deployed in ways that of varying configurations. So I think we're kind of there on the technical journey, rather than it necessarily involving telecom providers at this point. I think our perception to date, and this is mostly my view, just to be very clear, is that we are prioritizing lower security use cases for just now to demonstrate through the adoption curve that it can meet lower security requirements, and then as time goes on, it's like more critical initiatives. We don't know where the boundary will be drawn in terms of criticality of data that will be exchanged across this. That's still TBC. But I believe that as the technology curve increases and particularly the security requirements might increase with them, I think there will be a junction when we need to understand the relationships between using it with telecoms. So at the moment, it's not something we're exploring, but it's something that we're not quite on the upward ramp of needing to go there quite yet.
Great. All right, thanks. I'm not seeing any more questions, so I think we can probably. Oh, hang on. Tim wants to come in with something.
I was just reflecting on what you were saying, Greg. And do you see a point where we kind of have these virtual energy systems for kind of across Europe, across the world, but then because energy is so integral to many different parts, maybe I'm thinking of getting too hard of myself. Would you start to see that as like a whole big? We'd have the whole world kind of virtually modelled.
I mean, anything's possible, right? We've all seen The Matrix. So I think we're bounded and we're concentrating on GB right now. However, it's probably worth noting that there are other similar initiatives globally. So I'm aware that within Australia there is Project Edge, which is specifically looking at a kind of an equivalent way of sharing data. So it's a very similar approach to what I've described. But they're looking at it from a kind of flexibility perspective. It's being led by AMO, their market facilitator, I believe, is their kind of role in the market. I know, and for the life of me, Anka might be able to help out and put it in the chat, but there is European Union kind of data spaces, I believe it's called. That's also looking at kind of very similar methodology and scalability challenge. And I think we will be engaging, or we have been engaging with those programs, and we will continue to engage, so that in theory, the data exchange that is being facilitated here can also be replicated elsewhere, and that there, while it might be very difficult between kind of geographical regions to retain the same data standards, if you like. So, you know, Europe may call something A and GB might call it B and Australia might call it B.5, right? But rather than having each individual kind of company calling their own things, if we can kind of pull it together to a national level, it does make it a lot easier, and then you can do that kind of exchange. And then I am aware that there are kind of companies doing innovation with just the open data that's available and trying to do things across the globe, not just within a localized region. So I think, you know, we've got this custodian division for the UK, which is is very ambitious. I think what you described is Star Trek, right? But I think we need to shoot for that and see how far we get quickly.
Yeah, the EU data spaces that you mentioned, a portion of that is called Synergies, which is an innovation project in Spain. And that was actually featured at our previous webinar. So if you're interested, you can check that out. But we had a question come through in the Q&A from our director, Luciano. So he says that data interoperability and data sharing platforms and infrastructures are very relevant topics for the ongoing power system transformation. Can you comment on data ownership and privacy, etc.? There are many different uses of data, so the power system stability data needed by the TSO, data for strategic planning, data to provide advanced services to end users, many different data and related uses. So can you comment on the ownership and the privacy of that data?
Yeah, so within the virtual energy system, we've kind of got a number of, what's the word I'm looking for here? Our approach, because I can't think of the word I'm looking for. Our approach is that data ownership is retained by the data custodian. So if I'm an organization and I want to exchange data with Tim, okay, and his organization, then it is still my data, it's my responsibility. And this data sharing infrastructure, this kind of first part of the development of the virtual energy system, facilitates the exchange of that information. It doesn't go centrally anywhere. Some metadata would go into a data catalog, but fundamentally the data is still retained my ownership, and I am granting access or providing access, sending that data to Tim for his purposes that are pre-agreed. So we would, part of this data sharing infrastructure is a scalable technology, but there's also scalable legal agreement. And that's part of the innovation that we're exploring. So within that scalable legal agreement would specify things like data ownership and privacy and all those other considerations, data licensing, and do that in a kind of common language way, so that if many organizations enter into this data sharing infrastructure, they all understand that when legally I say, you know, this is the number one, everyone agrees that that is how we are representing the number one, or that a volt is a volt, or that a kilometer is a kilometer, whatever standard to that we're talking about. And that means that when you get down to an organization level, you can start specifying and saying, okay, if I as NESO, I'm happy to share data with all of the UK energy networks. Okay, well then this legal framework will very clearly specify who a UK energy network is. Okay, great. So National Grid Electricity Transmission, there I can exchange data with them. And then I can maybe set my data to say, okay, I'm only happy for that data to be shared and used with a subset of people within the category of distribution networks or transmission networks. So only they will be able to request access and be granted it. Or maybe I say, actually, I want to approve everyone who ever requests for it. And you can specify and kind of tone up and down the technology as required. For the earlier use cases, we're looking at kind of granting data at an organizational level. And then as we kind of develop through time, being able to be more fine-grained, and the technology choices that we're making should enable us to take that all the way to the nth degree in theory and be able to specify this data set. I'm happy with NEHA getting all of the data within it, apart from one data point in it, and I can redact that. So we're trying to enable the widest possible amount of use cases through the technology choices that we're making now, and then scaling it and firming it up as we go. Hopefully that kind of answers the question.
All right, great, thanks. So I'm not seeing any more questions. Oh, just as I say that, another one pops up from Luciano again. Looks like this one is for Neha. So EV smart charging is or could be a low-hanging fruit, whereas V2G is still lacking behind. What do we need to improve in order to exploit V2G by 2035 or possibly earlier? So is it car manufacturers' full involvement, interoperability, proper remuneration, regulations, or other things to consider?
I think one of the biggest concerns that comes with V2G is the discharge and charge cycles and the impact that has on battery capacity. And that was shown through the consumer behaviour surveys that were conducted. That was the limiting factor when it comes to adopting that technology. So in terms of the technological advances that are required to overcome that challenge, I couldn't comment myself what exactly is needed, as that is driven by the manufacturers that are out there. But it's definitely one that NGET is interested in, because the faster we can adopt that technology, then the sooner we can connect more EVs to the network and benefit from the additional storage on the network.
Great, thanks. All right, I think we'll draw to a close there. So just before we do, I'm going to share my screen one more time just to show this slide here, to highlight that next month we'll have another webinar. It's on the 8th of November at 1 p.m. European time. That will be 12 p.m. here, I believe. And that will feature the Longer Duration Energy Storage Innovation Programme in the UK at the Department for Energy Security and Net Zero. So keep your eye out for that invitation coming in the coming weeks. But with that, I think I'll thank our speakers from National Grid and NESO one last time, and thank everyone for their attendance today, and hope to see you all at the next one. Thanks very much.